We usually picture science as this slow, steady process, right? Like someone in a lab coat patiently collecting facts one by one until a truth is proven. But what if that whole picture is just completely backward? Today, we're going to dive into how science really works. And cast me, it's not a slow march. It's more like a series of daring leaps into the unknown. And it's way more exciting than you might think.
So that gets us to the big question here. How does science actually move forward? Is it all about proving ideas, piling up evidence until a theory is finally set in stone, or is the real engine of progress something else entirely? Okay, this is the core of it right here. On the left, you've got the common belief science is about collecting facts to prove theories true. But the reality, on the right, is basically the opposite. Real progress comes from making these bold, creative guesses and then doing everything in your power to try and break them, to prove them false.
So first, let's unpack that popular view, the one most of us probably learned back in school. It seems to make perfect sense on the surface, but as we're about to see, it has a huge, fatal flaw hiding right in plain sight.
This popular idea is built on what's called the inductive method. And the concept is pretty simple, really. You start with specific individual observations. The source material calls them singular statements. And from those little pieces, you try to climb your way up to a big, universal theory that explains everything you saw. And it feels really intuitive, right? You see one white swan? Okay. You see another one. Then you see 1,000 of them. After you've collected enough of these observations, you feel confident enough to climb that ladder of science and make your grand conclusion. All swans are white. It feels solid, it feels safe, it feels certain. But is it? Well, this is where the whole thing just falls apart. This method that seems so solid is actually a myth. Because a million yeses, a million observations that agree with your idea, can never, ever truly prove a theory.
And this quote just hits the nail on the head. No matter how many white swans you count, no matter how much evidence you stack up confirming your idea, your conclusion that all swans are white could still, at any moment, be shown to be completely and totally wrong.
This is famously known as the problem of induction. And it's a huge deal. There is a massive logical gap between seeing a billion white swans and being absolutely certain that all swans, everywhere, for all of time, are white. You just can't logically make that leap from a limited number of observations to a truly universal truth.
So, if induction is a bust, then what actually works? Well, this brings us to the real engine of scientific progress, this incredibly powerful alternative called the deductive method.
Now, the deductive method completely flips the script. Instead of starting with observations, you start with a bold, creative, and, kind of tentative idea, a conjecture. And then, your job isn't to find evidence to support it. Your job is to try your absolute hardest to prove it wrong, to refute it through the toughest test you can dream up.
This shift in direction is everything. Induction tries to build from the bottom up, from little facts to a big theory. But deduction, it works top down. You start with the big theory, and you use it to make small, specific, and most importantly, testable predictions about how the world should look.
And this all leads us to the heart of the matter, the concept that really drives science forward: falsification. It's this powerful idea that a single negative result, just one no, is infinitely more powerful than a million yeses. Okay, let's go back to our swans, but this time we're going to do it like a real scientist, using deduction. We start by putting our bold conjecture out there. Our universal theory is all swans are white.
So now, we don't go looking for more white swans to pat ourselves on the back. No. Instead, we deduce a very specific prediction from our theory. If my theory is true, then the very next swan I find has to be white. Then we set up our experiment. We go looking for swans, specifically to put that prediction to the test.
And then we find one. But our observation is a shock. It doesn't match our prediction at all. We see a black swan. And boom, in that one single moment, our entire universal theory comes crashing down. It has been decisively, completely falsified, proven false. That one little observation did something that a million confirming observations could never do. And the logic behind this is just ironclad. Think about it. If your theory says X must happen, and then X doesn't happen, well, then your theory must be wrong. It's a clean, logical break. There's just no arguing with it.
This means that any real scientific test can only have two outcomes. If your prediction fails, your theory is falsified. That's a permanent, definitive result. But what if the prediction succeeds? What if we did find another white swan? Well, the theory isn't proven. It's merely corroborated.
Corroboration just means that your theory survived this round of testing. It has, as the source material puts it, proved its mettle. It gets to live to fight another day, but it's always vulnerable to the next test, the next observation that could finally break it. It's never proven true for good.
So, what does this all mean for how we as a species actually learn and grow our knowledge? Well, it paints a totally new picture, one that isn't about the arrogance of being right, but about the humble, ongoing process of just becoming a little less wrong every day. I absolutely love this analogy. It just makes so much sense. Science isn't some pristine museum where we display perfect, finished truths. It's more like a chaotic quality control lab, where we're actively trying to smash our own best ideas, pushing them to their breaking point just to see where the flaws are. Only the very toughest theories make it out.
So the real path to progress isn't about stacking up facts. It's a non-stop cycle of correction and improvement. We find a flaw, we toss out the old falsified theory, and we replace it with a better one. A new theory that explains everything the old one did, plus the new, troublesome fact that broke it. The goal isn't to arrive at some final, absolute truth. It's to get closer and closer to it by chipping away everything we discover as false.
And that brings us to a final thought, one that's a little more personal. See, this way of thinking isn't just for scientists in labs. We all hold theories about the world, about other people, about ourselves. So I'll leave you with this. What's a core belief that you hold dear? That might just be one critical test, one single black swan observation, away from being completely falsified.